Auto-responsive technologies, criteria for usage in opaque facade thermal rehabilitation. Auto-responsive technologies operate on intrinsic mode, enabling the users of the reaction to environmental stimuli in a positive way without processors or external power. They represent a huge potential to implement thermal adaptive strategies into building envelopes. The scope of this communication is to discuss criteria for the use of these technologies on opaque facade thermal renovation. In this analysis, certain technologies were considered which are triggered by variations of temperature, humidity, and solar radiation that can contribute to 9 different thermal adaptive strategies. The selection method is established by applying the criteria to the strategies in which the auto-responsive technologies can be useful. 4 criteria were analyzed: climate suitability, thermal behavior compatibility, constructive, and urban constraints. The qualitative allocation of each thermal adaptive strategies into zones of a building bioclimatic chart, BBC, indirectly allows to establish the climate adequacy of each technology. The BBC is a psychometric chart permitting the representation of the relationship between air temperature and humidity conditions of a given geographic location. Furthermore, it identifies different zones that correspond to conditions of occupants' comfort or to conditions in which comfort can be achieved if a specific building passive design strategy is implemented. For this purpose, the Climate Consultants tool, which graphically analyzes climate data, is used. The correspondence between each thermal adaptive strategy and some of the design strategies listed in the BBC is possible considering the adequacy of weather conditions for each strategy. For example, the solar reflectance adaptation strategies of the external cladding control solar radiation absorption. This can be achieved using thermochromic technology. This technology allows us to change the reflection coefficient. To prevent overheating, high reflection values are desirable, but the opposite is advisable to enhance solar gains. This strategy is suitable when BBC 10 and 11, corresponding to passive solar direct gain with low and high mass, and BBC 2 corresponding to sun shading of windows are both recommended to a given location by climate consultant. Although BBC 10 and 11 refer to passive solar direct gain, which imply collecting solar energy through the transparent envelope directly indoors, such as solar reflectance adaptation, they work when solar radiation is available and we intend to take advantage of it. BBC 2 is recommended when available solar radiation is not desirable, corresponding to the thermal adaptive strategies in cooling mode. Considering the solar reflectance adaptation strategy adequacy time for different climates, it is possible to observe that climates with a higher temperature range and lower sky cover take more advantage of this strategy, as in the case of Alice Springs, Australia. This climate has a higher percentage of use time and cumulatively a more balanced use mode between heating and cooling time. Port City climate use these strategies in a more unbalanced way, with only 3% in cooling mode, easily explained by the 30 to 60% of sky cover in the summertime. Comparing sky cover in Faro and Évora cities, Portuguese climates both with CSA Copenhagen classification, it is possible to justify the higher percentage of the heating mode of the solar reflectance adaptation strategy in Faro City. Even in winter time, Faro City has sky cover under 60% most of the time. Concerning the thermal behavior compatibility criterion, it should be noted that the thermal resistance of the existing facade can limit the potential of strategies that are highly dependent on facade's heat flow, namely solar reflectance adaptation. Therefore, it is recommended to use those strategies in existing facade with low thermal resistance. 3 constructive aspects are considered for the auto-responsive technology's applicability: geometric irregularity of facades that restrain the application of modular cladding elements compromise the implementation of strategies that imply facade configuration changes, namely self-ventilation and shading control. The existence of a wall cavity is mandatory to implement the convective-conductive heat transfer control strategy. This is of implementation concerning the technology's connection type with the existing facade, which can be classified on a scale from A, the simplest one, like painting, to D, the most difficult, implying several mechanical connections. Urban constraints are related to space availability and facade shading. For the implementation of strategies such as self-ventilation and shading control, outdoor space is necessary. Indoor space availability is required for other strategies, such as storage control. The implementation of the self-shading control strategy does not make sense on facades that are continuously shaded. It is also possible to take more advantage from solar flatness adaptation and integrated hygrothermal control outdoor strategies when implemented on unshaded facades. The described method can be synthesized in this way. First, early climate data in EPW format of a specific location are introduced in the climate consultant tool in order to generate a building bioclimatic chart in which the percentage of time adequate to each BBC strategy is indicated. The time that each thermoadaptive strategy is adequate to that specific climate is obtained by summing up the time of each BBC adequacy considering their correspondence with the strategies. After climate criterion application, the limitations and recommendations of the other criteria are observed in order to exclude the thermoadaptive strategies not adequate to a specific case. This way, the auto-responsive technologies useful for the remaining thermoadaptive strategies can be selected. We intend to perform more in-depth tests concerning the methodology applied to the climate criterion in order to systematize the suitability of auto-responsive technologies to different climates, which will be useful for calibration purposes. Thank you.